Hi everybody, my name is Nicole Dixon and this is an overview of my research project plan entitled Attitudes, Motivation, and Instructional Practices in Mathematics. I decided to look more closely at this issue based on a unit that my students were doing in my classroom. It was a data and graphing unit in which students were surveying each other about their favorite subjects. It turned out that only 1 out of 16 students reported math as his or her favorite subject. This really piqued my interest in this problem. Multiple students in my 3rd grade class were having a conversation about disliking math, and they were naming various reasons, which were all a little bit different. One student even went as far as saying that he didn't like the color of the pages in the workbook. Some of the 2nd grade teachers also mentioned that their students often groaned every time they were told it was time for math. And a few 4th grade students with whom I'm familiar approached me randomly in the hallway to discuss their negative feelings about mathematics. Now, one of the main problems is that at our school, our scores on MAP tests are strong, but this doesn't mean that the students actually have positive feelings toward mathematics. This made me want to look deeply at attitude toward mathematics based on these conversations with students and teachers at my school. My initial research question was, how will modifying instructional practices in mathematics affect student understanding and attitude toward mathematics? Based on that question, I developed a quantitative needs assessment using a survey with a 5-point Likert scale. The focus was really on students determining how much they agreed or disagreed with 5 different statements, including math is my favorite subject. I think that the math lessons are interesting. I'm encouraged by the way my teacher teaches math. I like completing math problems in my student math journal, and I am good at math. I initially administered this survey to the 3rd grade students, including my own and the other 3rd grade classrooms. Across the 3rd grade, you can see that students have neutral feelings about mathematics. They're kind of in the middle. Some people are agreeing, some people are disagreeing, but for the most part, feelings are neutral. The majority of students are encouraged by their teacher and the way that they teach math. And many of the students have neutral or negative feelings about the coursework from the mandated curriculum, which is the student math journal. The student math journal is what students complete all of their work in, and it's just a regular math workbook. So based on these findings, I determined that there's no correlation between confidence in mathematical abilities and attitude toward mathematics. Many students stated that they agreed that they were good at math, but they still didn't say that they thought that it was their favorite subject. I thought that this struggle with mathematics could be based on the fact that the grade 3 curriculum is much more challenging and the students dislike completing these tasks in their math journal. There was a strong correlation between confidence and ability and student relationships with teachers. So then I decided that I wanted to compare the grade 3 results with those of grade 2 and grade 4. I surveyed between 30 and 45 students from each grade level to collect this data. Now, the majority of students in 2nd, 3rd, and 4th grade have neutral feelings about mathematics. The students were encouraged less and less as the grade levels became higher. So in 2nd grade, students felt very encouraged. 3rd grade, still pretty encouraged. 4th grade, though they agree that they're encouraged, that average has gone down. 3rd grade has more negative or neutral feelings about the mandated curriculum from the student workbook. This could be because the content really spikes up in 3rd grade and then levels out again in 4th grade. Students feel less encouraged, and it seems like there's still no correlation between confidence in mathematics and enjoyment of mathematics. To follow up with my quantitative data, I decided to do a qualitative needs assessment, which was developed based on student ratings on the initial mathematics survey. I wanted to gain greater insight into the student answers. Students who said that they did not enjoy math, I wanted to know why or why not. I wanted to know what they felt like they usually did during math lessons, what their teacher did during math lessons, what teachers thought about math lessons, so the perception that students have of their teachers' feelings about math, what they actually like about math lessons, what they dislike about math lessons, how they might change them to make them more interesting, and I wanted to know a little bit more about why or why not they felt they were good at math. I also added another bit of quantitative data gathering just so that I could start thinking about ways that I could change my instructional practices. So I focused on whether or not students enjoyed using technology. Do they enjoy math projects? Do they enjoy math being a challenge? And do they prefer to work alone, with a partner, a small group, or with the whole class? Based on the answers that I got from this questionnaire, I did some initial coding of the questionnaire results. So prior to looking at the results, I had some predetermined themes, which were feelings about mathematics, so positive and negative feelings, student perceptions of their self during math time, student perceptions of their teacher during math time, as well as instructional practices that students like and disliked, including also the self-image of students, so their positive self-image and their negative self-image. I color-coded the responses in order to determine the most frequent answers. And then I included some initial interpretations of the data to determine what students thought was most motivating or demotivating, as well as the areas of the classroom and of the teaching that students felt like they liked and disliked most. I also used the data from the bottom, the quantitative data that I gathered, to create another graph, and so that I could start thinking about mathematical instructional practices. Overall, the students in my own third grade classroom would like more technology incorporated in math lessons. They prefer math projects, and they also prefer working in teams and partnerships. Now, this could be, all of this data that I've gathered could be based on the time that we were taking these assessments, the unit that we were in, and so they're really only accurate for the moment in time in which they were taken. But I coded them anyway to determine final themes from the questionnaire, in which I really tried to pull out themes that were based on the most frequent responses to questions, and I provided examples of student remarks and data from the survey to support those themes. So I determined that one of the themes was math can be fun, math is hard, math is boring, extra math and student math journals aren't enjoyable, and high interest in math projects, high interest in using games and technology, students who listen, sit a lot, and do extra math during math time, students who feel that the teacher teaches, and tells the class what to do, and then also some examples of positive self-image about math abilities and negative self-image about math abilities. Now, based on my needs assessment, the overview basically stated that students dislike extra math, which is a fact practice program that gives students a set amount of time to solve math facts, and it is based on the iPad. They also dislike the monotony of the mathematics curriculum. The students who say that they dislike math consistently stated that it was either too difficult or boring for them. Many students enjoy using technology in math class. They enjoy working with partners and small groups in math class, and they enjoy projects associated with mathematics. Now, some decisions that I made based on the data analysis are a need for modifying instructional practices, including opportunities for engaging experiential learning and projects that support the curriculum, the use of differentiated technology, and a focus on autonomy, meaningfulness, belongingness, and competence. The literature that I read, the many articles that I found and combed through, highlighted the connection between attitude toward mathematics, motivation, and achievement. The majority of these articles really focused on the fact that students' performance in mathematics and their feelings about mathematics were related to autonomy, meaningfulness, belongingness, and their feeling of competence in that particular subject. I also looked a lot into quantitative assessments developed by Yi Lim and Chapman, and the structure that they used for gathering quantitative data using a short form inventory that can be completed in less than 10 minutes. Throughout this process, some of the questions that drove my thinking were, how could my students become more excited about learning mathematics? How could my teaching incorporate instructional practices that support the common motivational theories of autonomy and meaningfulness? And what should I change about myself to promote positive attitudes about mathematics? This led me to determine my final research question, which is, how will modifying mathematics instructional practices to include more experiential learning activities affect student understanding of and attitude toward mathematics? I developed an action plan, so I'll begin by exploring various ways of teaching lessons that allow students to make choices, collaborate with classmates, and make connections to the real world. Much of this might be based in project-based learning or inquiry-based learning. I will implement these hands-on or experiential learning activities over 3 phases, which is approximately 12 weeks. In phase 1, I'll focus on the intervention and incorporating experiential learning into the curriculum for a full unit, and then gathering data. For phase 2, I'll return to the traditional math curriculum for a full unit. And phase 3, which will be the final unit, I'll incorporate experiential learning again. Throughout this process, I will be constantly reflecting in the moment and reflecting on what happened during the lessons in order to optimize the effectiveness of the lessons. Throughout the process, I will be doing many assessments in order to analyze the effects of the action over time and to determine if my intervention is actually causing growth and greater attitude. It's very important that when you're conducting research, you collect a diverse body of data to determine the effectiveness of the action plan. My assessments will happen throughout the research process to analyze these effects over time. After the same sampling of quantitative and qualitative data has been collected in all 3 phases, I will cross-validate my analyses of the data through triangulation. So I'll start out by doing quantitative data gathering, followed up by a questionnaire, and then follow-up interview to clear up misconceptions and take further notes. Throughout implementation, I will make observations of students and their engagement and interest in tasks, and do quick interviews with students about various lessons to see if they have increased or decreased engagement from their own perspective. After implementation, I will re-administer the math attitudes and survey questionnaire and interview students to see how they felt about the experiential learning practices. Hopefully, this will give me a lot of information about my research, and here are the references for my literature review and many pieces of information that were helpful in this process. Thank you for listening.